Welcome to iAfrikan Media, iAfrikan Bytes, live from Deep Learning Indaba. You know, one of the beautiful things I love about the Deep Learning Indaba is the fact that great African minds converge here. You know, great African minds that on a normal day you would not even interact with, simply because you find them all over the world. And one of those great minds is my sister here, Flora Tasse. Now, Flora works for NVIDIA. Now, if you're a gamer or anybody into technology, you definitely know who NVIDIA is. NVIDIA has been very instrumental in creating chips and computational, processes that help or have shifted the gaming world. If you remember 1999, it gave us the G4 series, which ushered in 3D graphics, which changed the gaming landscape. If you remember back in the day, games like Battlefield, games like Call of Duty. I know I'm a big Call of Duty fan. I still play till this very day. NVIDIA has been very instrumental in, ushering in that graphic 3D, 2D graphical world in terms of gaming. Flora, thanks for joining us on iAfrikan.
Oh, thank you.
Now, Flora, you are NVIDIA Principal Machine Learning Engineer. Very, very beautiful title. What does a Principal Machine Learning Engineer do?
Well, at its core, it's still being a machine learning engineer, learning how to take ML and apply that to our products.
Mm-hmm.
At the principal level, you are working on more cross-organizational products and trying to support my team and other colleagues in accelerating our path to our products, improving the tech behind it, and making it more accessible to others.
Now, Flora, you work at the Seattle office, right?
Yes.
The head office is in Santa Clara,
Yes.
in California. Now, what happens at the Seattle office? I know you have your robotics lab, but what happens there?
So it's home to really our robotics research.
Okay.
But it's not just robotics, right? You have other teams that are working out of that office, and so it just gives way to a lot of collaboration between different teams. And I would say it's robotics at its core, but other teams have also kind of leveraged that venue.
Now, Flora, I read one of your research papers, very fascinating, and I want to talk about that research paper. It's actually your most cited research paper. It has 66 citations, and it's called the Cluster-Based Point Set Salience, right?
Yeah.
And you published that in 2015. Now, I want to ask you a question. Can you explain what is point set salience and how is it important in terms of 3D shaping?
Yes, so I will start with, for instance, what's a point set? Really, a point set is a 3D data representation of a space. So I would make an example of a building or a city. You could take a depth scanner and scan that building, scan that city. What you get at the end of the day is a set of 3D points in space. So that's a point set. And then the saliency is really trying to find out what is the most interesting part of that point set, that a representation of a real structure. And so when I was working on point set saliency, it was about how do we automatically find out what is the most interesting part of a large structure, and how do we do that fast and efficiently. So that's really what that research was all about.
So how does your approach differ from traditional, mesh saliency models?
Yeah, so really, the capturing point sets is a bit cheaper than constructing a 3D mesh.
Okay.
And so a lot of techniques that people have out there for 3D mesh do not apply to point set. See, a mesh is a point connected with an edge.
Okay.
Whereas in a point set, you just have points randomly in space that have no connection. And so you need a different set of techniques to be able to process that. And so my technique was cluster-based. That's a key point in that, because rather than trying to look at points individually, we really look at the cluster. So you are taking your point cloud, you're actually separating it in different clusters, and then trying to identify how a cluster is, how important it is by comparing it to its neighbors. See, that makes it very efficient because you're no longer working at the level of point set, you are working at the level of clusters. And so you can have different level of resolution depending on how precise you want your saliency to be.
You know, as you're talking, I'm looking at you and I'm like, my goodness, Flora, you're really good in what you do.
Oh,
And like, you really know what you're talking about.
thank
And it's
you.
so amazing. In terms of point salience, right? The amount of citations you got from this paper, 66, did it shock you? Or was it like, okay, let's just publish it and we'll see what happens? The reaction that you got, how was that for you?
I mean, it's very good to have your papers being cited. I think at the time when you are doing your research, when it's really something, you don't do it because of the citations. You do it because you think it's an interesting approach and that there will be value in publishing that into the ecosystem. And really, some people might find it useful, some people might not. In any case, it's going to advance the state of research. And so when you get lucky and a piece of research that you've done kind of is being picked up by others, it really validates that, there's something about that approach that people are finding valuable. So I'm very happy that it's getting so much traction.
Flora, NVIDIA does a lot of work in 3D.
Yes.
Now, give me a practical application or scenario of
Yeah.
where your cluster approach to, point set salience, what does it find application in industry, in gaming, in computer vision? Draw that picture for us.
Sure. I think one of the applications I mentioned in the paper was being able to do viewpoint selection.
Okay.
So imagine that you are maybe capturing a whole city and you want a tour of this city. Question is, what are the most interesting parts of this big city? And without necessarily having someone sit down and hand label it. And so you can do things like automated tours of big areas using this method because you automatically find out what are the interesting viewpoints from which the camera from where the camera should be.
Okay.
So that's one application, really, viewpoint selection. Another application is in manufacturing sector. And even though NVIDIA is gaming, we are involved in many other industries.
100%.
Exactly. And we are all about 3D data and understanding what
Okay.
3D data means. So manufacturing, where you want to maybe determine things that are out of anomaly detection, things that are strange, things that are not the way they should be. That's one way of automatically finding it out without having someone go through a huge amount of data. So those are some of the applications for this.
Now, Flora, there are students, graduates that are thinking about, area of specialization. There are students and graduates currently doing their undergrad. How would you advise, a student or a graduate intrigued by this conversation? And how would you talk to them to make them understand the level of opportunities in this specific sect of artificial intelligence and machine learning?
Yes. You know what? I find 3D data so interesting because there's a lot of work, important work happening in NLP, important work happening with images and videos. But I find 3D content so interesting because we live in a 3D world. And so if you can understand 3D content, you understand the world. And so our students, I really encourage them to look into AI applied to 3D. Really, there's not a lot of work happening there. And so it's just a huge opportunity for anyone who wants to work in that space. And there are various ways to do that. I would say 3D itself is massive. So you want to pick something that is interesting to you. Maybe it's large structure like buildings. Maybe it's smaller things like proteins, right? Maybe it's like indoor scenes. Maybe it's car, self-driving car, and you want to understand the space around you so the car can drive safely. Pick a sector and then just kind of start playing around with that, start tinkering with that concept. And when you start doing that, you start figuring out other work around that space, you start building skills, a skill set around that specific area.
If you're wondering, ladies and gentlemen, why are we sweating? We're outside. We're outside at the library at the Mo University. It is 33 degrees Celsius. But because Flora, a birdie told me Flora loves Flora and green and all things pretty. So we came outside just for her for this special interview, right? Now, Flora, how is it working in AI machine learning in a country like America, coming from Cameroon, and now being in Seattle? How's the environment? How's the culture? from an academic point of view, from a professional point of view.
Yeah.
How is that environment?
Yes. You know, it's very interesting because I've been to 3 different continents.
Okay.
So I've been from Cameroon to South Africa to the UK,
Okay.
and now the US. So it's interesting to see the differences between the different countries, even countries, cities. It's very different. I would say that in the US, a lot of the methods that we use today really started gaining traction there. When you think about deep learning, when we think about transformers, a lot of that work came out of like US universities. And so I think being there, you are really very close to the action. So that's a big advantage. One thing that also says that there's a lot of funding into AI products, AI startups, AI technology. And so wherever there's funding, it accelerates the rate of technology, right? Accelerate the rate of research. Personally, from a personal standpoint, I think it's been great in terms of opening my eyes to other areas of AI because it's so big.
It's so big.
Right? And you can't read every paper. Guys, you can't. So really you want to talk to people, and the more you talk to people working on different interesting things, the more you are learning and the more you are kind of figuring out how you can use different things in your own
100%.
area. Yeah.
What value can African scholars in AI bring to countries like Europe, like America? What do we have as African scholars in AI that you don't find in Europe, in
Yeah.
America? Why do companies want a person like Flora and not a Tom, Harry in America from Seattle?
Yeah, that's a great question because it brings us back to, the problems that in these European countries or American settings, they are dealing with a lot of funding. They are dealing with a lot of resources, a lot of compute, and therefore some of their methods are taking into account some things are for free. Whereas in the African context, well, you have to think twice about how long this tech is taking.
100%.
What technologies do I need? How much compute? How much GPU? How many GPUs do I need for this? Electricity costs. These are issues that we are dealing with. And what that means is that we can now develop solutions that are targeting those type of scenarios. We can be more efficient, whether it's in terms of money, resources, time. And that is not only good for us, it's just good for everyone, right? We are driving the cost of deploying these technologies. Everyone is going to benefit. I think that's a superpower that we really have and that no one else has. When you have to deal with limited resources, that's when genius happens.
So basically, ladies and gentlemen, Africans, we know how to do a lot with little.
Yes, yes, we do.
Flora, thank you so much.
Oh, thank you.
It's been amazing talking to you.
It's been a pleasure.
And now you're a friend of iAfrikan Bites.
Yay! When do we have coffee? I need to meet everyone in the community.
Come on
when
now.
are they getting together?
Subscribe and comment. She asked you guys out for a date, so you subscribe and comment, and we'll hook you up.
Thanks.
Thank you so much.